All right, so this is an area of a polar curve, and we're just going through the different questions they're going to ask. So this one is finding one loop. That's it. We just want the area of one little loop. So we take this and we break it into what we can use to plug in our calculator. And you plug it in your calculator or Desmos, and we'll do both just to get a better picture of it. So I've already plugged it in, and I've already changed my window, and I've put a 0.01 for my steps, so I get a nice smooth graph. And you can see this is what it's giving me. So if I go back and change it again, let's speed it up a bit. There's the blue, and then there's the red. So the red and the blue are giving us the same. So I can get rid of this one and just go back to the blue. So that's what I'm going to focus on, just that one guy right there. And so what we're looking for is this. If you look at Desmos, it's a little bit nicer here. So it's shading the whole thing as I go from 0 to 2 pi. But what I need is just this one last loop. But if you look at, if I go from here to here and I shade just this, I can quadruple it. So I know at t0, I'm here. And so what I just need to do is know, okay, well, what is the angle value? That will give me an r value of 0. This is when my radius is 0, right at the center there. So here, let me just draw that on there. So right here is r equals 0. So I know right now that's my theta equals 0. So I'm going to be going from 0 to something to get this little region here. So if I can find out when r is 0, it'll tell me what to use. All right, so if we set this equal to 0, I'm basically getting cosine of 2 theta equals 0. So theta is equal to 0, or sorry, cosine is equal to 0 at pi over 2 plus pi k. So if you remember your unit circle, cosine is 0 here and here. So at pi over 2 plus pi. So that means theta would be pi over 4 plus pi over 2k. So now I know when it's 0. It's going to be at pi over 4. So I'm going to get values like this, pi over 4, and I'm going to add pi over 2. So 3 pi over 4, that would also give me 0. And then going in the other direction, negative pi over 4. So if you look at the little red dot, right, it actually goes negative this way. So that means if I change these to negative pi over 4 and pi over 4, it'll give me this. And if I change this to negative pi over 4 and that to pi over 4, it'll shade it in. So if I make this negative pi divided by 4 and pi divided by 4, you'll see that's, yep, see, it's just that one leaf. So that one leaf is created by negative pi over 4 to pi over 4. So if I do the same thing here, started at negative pi divided by 4, and then change this one to pi divided by 4, boom, see, shaded it all in. So my actual integral would be negative pi over 4 to pi over 4. But what I'm going to do is do 0 to pi over 4, and then double it to just give me this one loop. So we're going to go from 0 to pi over 4 and double it, because again, this whole thing right here is negative pi over 4 to pi over 4. So now we can plug it in, and it's 1/2 r squared theta. So 4 cosine 2 theta with a square root squared. But what we're going to do is just basically plug it in. I'm going to actually write it. 1/2 r squared d theta so that you can see what's going on. So it's 2 integral 0 to pi over 4, 1/2, and our r squared here is 4 cosine 2 theta d theta. So doing a little simplifying, we get 0 to pi over 4. I'm going to put the 4 on the outside. Cosine 2 theta d theta. And then integrated, this would be 1/2 sine 2 theta times 4. So we end up with 2 sine 2 theta pi over 4 and 0. So we end up with 2 sine, and that's going to be pi over 2 as we plug it in, minus 2 sine of 0. And so sine of pi over 2 is 1, so our answer is 2. But we need to make sure this is true. So math 9, and we plug in exactly what we want. So it's from 0 to pi divided by 4, and we can just double it at the end, so I'm just going to plug in the inside. In fact, the 1/2 and 2 cancel, right? So it's just 4 cosine 2 theta. 4 cosine 2 theta d theta, and there it is, 2. So I just canceled those two to plug it in. That's an easy cancel. But there we go. So when you're looking for one loop, what you want to do is find out when it starts and when it stops. So you want to find those locations. Zeros are perfect to look for, and it'll tell you what the values are. Then you want to go to your graphing calculator and Desmos. So if you go to your graphing calculator, you can change them as well to pi over 4. That's what we had to verify it. And you'll see it graphs just what we want. You can hit trace and then put in pi divided by 4. And it tells you it's 0, 0, so that also verifies it. And then also use our Desmos graphs to plug them in here and here. You've got a link for this. You can change the function to anything you want. You can look at it as it moves around. So play with them until you get the right values that you need. Use the technology we have along with our basic algebra skills to work these problems out. So they're just basically asking you different questions to find different areas. And the next one, we're going to look at areas between two curves.